Here we go. All right, so we're reviewing our polynomial end behavior, and that's because we're going to talk about end behavior one more time before we lead into rational functions, because that's when your end behavior starts to get a little bit of weird and funky. Okay, does anyone know why rational function behavior gets weird and funky? Anyone remembers what makes them special?
Plus or minus?
It has to do with a fraction. It's not plus or minus. Asymptotes.
Oh yeah.
They have
I haven't
asymptotes.
heard that in a while.
Okay, they have boundary lines, and those boundary lines start making our end behaviors act funky, right? So we just want to make sure that we have a strong understanding of end behavior before we dive into that. Got it? Okay, because that's what 1B.7 is asymptotes, yay, of rational functions. All right. Huh? We're on B. No, I'm saying that's what we're reviewing so that we can do good at it. All right, so here we talked about when you are looking at the leading coefficient of a polynomial, the power function eventually rise or fall without bounds, right? It's either going up forever if it's, what is this? What function? Same behavior? Even degree, right?
Yeah.
Quadratic is an even function. So yeah, good job. Okay. And then if I do this, we are odd degrees, right? Even degrees, even behaviors, odd degrees, opposite behavior, right?
What is this one?
Which one? Odd.
No, I mean like.
It depends on what's happening in the middle. Whatever's happening in the middle determines the rest. I don't know how to describe it. Okay, I did not know how to describe it. I'm running on minimal sleep, guys. Let me be great. All right, here we go. So the main things we're gonna look at is our degree. So the first thing you're gonna look at is your degree, and you're looking to see if it's even or odd. That's gonna give you a head start to where you're going, right? Okay, and again, we're gonna remember that even behaviors are gonna have same behaviors. So either they're both going up or they're both going down. That's our even. Okay. Our odd behaviors are going to be doing the little boogie and doing different things, right? Yes, I did put it right here. Welcome. Okay, so this makes odd. Yeah? Boom, boom, boom. One's doing the YMCA. The other one's doing a little boogie town. Okay. And then the next thing you're going to look at is your leading coefficient. Okay. Your leading coefficient. Does anyone remember why we look at the leading coefficient? See if it's positive or negative. Okay, that positive or negative tells us how our function ends, what's happening to the right. This determines right-hand behavior. Determines right side behavior. So if I'm negative, that means on the right side, I have to end going down towards negative infinity. If I'm positive, that means on the right side, I got to end going towards positive infinity. It determines your right-hand behavior, your right side behavior. Okay. All right. Are we ready to do a little practice of this review? Does any of this sound familiar or is it brand new? Sounds familiar? Yeah, that's what I thought I heard too. All right. So we're going to look here at the... We're going to hide that so we can see. All right. So here we have first one. We're going to determine what is its leading coefficient sign. Positive. Why is it positive? The right side is going up. So it's positive because your f of x on the right is going towards positive infinity. So therefore our leading coefficient is positive. Agree? No. Okay. Our left hand, because it's odd, how do we know it's odd? They're opposite. As our right side is going to positive, our left side is going to negative infinity. That's how we know that this is an odd degree. Yes?
Yeah.
Okay. Next. Over here, this guy, what is it? It's going to be a negative. And why do we know it's negative?
Because it's right side.
The right side is going to negative infinity. And is it odd or even? Odd. Good job. And that's because opposite direction. So therefore we know it's odd. Okay. Bottom left, what's happening? What is our leading coefficient? Positive. And that's because our right side is going to, y is going to positive infinity. And it's an even function because the left side is also going to positive infinity. And our last one is clearly negative. And that's because our right side is going towards negative infinity. And it's even because they're both going towards negative infinity. Okay. Are we comfortable identifying and summarizing end behavior just graphically? Ha ha ha. We're gonna keep going. Here we go. So things summarizing what we talked about. Considering the domain and range for each degree family, what can we summarize? So as x goes to positive infinity and as x goes to negative infinity, what do you notice about the f of x or the y value of the graphs? What do we notice about an even? Let's start with even. So tell me what happens with on even functions. On even powers, what happens? What's the summary? The behaviors are what? They're the same. On even powers, end behavior is the same. Okay, and then our summary for odd is on odd powers. They're opposites, right? Different. I hope that's like grammatically correct. Oh no. Is that? Okay. Next, how does the values of the leading coefficient? So in summary, tell me, what does your leading coefficient tell you?
The right side.
There we go. So in summary, our leading coefficient determines what?
The right.
There we go. Determines the right side or right hand. So as x goes to positive infinity, that's our right side, right? If it's positive or negative. And based on whether it's odd or even, that's how we know what the left side is doing, right? Okay. Ready to put it together in some examples? So our first example up, we're going to use a calculator. So I'm going to have you graph it. You're going to tell me what is n, meaning what is your degree? What is your a sub n, which is your leading coefficient? So n is our degree. A sub n is our leading coefficient. And we're going to talk about your turning points. Your turning points are your extrema. Remember, that's where your number of extremas you have. And yeah. All right. Ready, set, break. Create my graph. I'll be walking around if you need help. Reset your calculators. Second plus 712. The LC, leading coefficient. Limit as x goes. Oh, this is saying as you're going to the left. This is saying as you're going to the right. So as x go to negative infinity, that's your left, right? And as x goes to positive infinity, that is your right. Second plus 712.
They both say negative.
Did the negative not print off on the first one? It should be negative and then positive. Sorry if it didn't print. I did print in ink saving mode, so I bet. Here we go. All right. So the first one, is it saying you're in? When we're saying your in value is referring to like just what is your degree. That's because they're talking about when it's in the form of a n to the x n power, blah, 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 and your formal long notation thing. But your n is your degree, and our degree is 3. So therefore this is odd, right? So from it being odd, we know our behavior should be doing what? Opposite. They should be opposite behavior. Should be boogieing it away. Okay. Next, our leading coefficient. Your leading coefficient in this case is even or mid odd or I can't even talk. Positive or negative? Negative. We were getting to that word. Okay, it's negative. It's at -1, right? So in my mind, I know that when I look at the graph of this, it should be an odd function that on the right side is doing what? Going down, and on the left side, it should be going up, right? So before even graphing, I can make predictions of what my limits are doing, right? So it says the limit as x goes to -infinity. Well, x goes to the -infinity as I go to the left. And as I'm going to the left, what should this function be doing? Heading to positive infinity. Agreed? Yes? Before even graphing, I can answer these things, right? Yes. Next, it says the limit here as x goes to positive infinity. Well, if I'm going to positive infinity, that means I'm forever going to the right. And what should our values be doing as they're going to the right? They should be going to negative infinity. That is a horrible infinity. We're just going to roll with it. It should be, it probably your arrow got cut off or the plus sign. I don't know. Well, let's just turn this into a positive. I think maybe the line got cut off. Okay. All right. So then we go to the graph. So when I go to the graph, I'm going to turn on good old Sylvie. Second plus 712, clearing her out. And when I clear, I'm here now at y equals, hey, it picks up everything right here. So we have negative x squared, and we have, not squared, y'all were going to let me write squared, and no one said nothing to me. Cubed, plus 2x squared plus x plus 1. Okay, so then when I go to graph, it looks like Sylvie's drawing real slow. There she goes. All right, so how many turning points do I have? 2, okay? Your max turning points, your max TP equals your degree minus 1. That's the max you can have. So in this case, what was the degree of our function? 3. 3 minus 1 is 2. So the max turning points I have 2, and where are they located at? Anyone found them? Perfect. So remember how to find them. We determine whether it's a maximum or a minimum, right? The first one is a minimum. So we go second trace, and you see where it says minimum. Press 3. I'm going to go to the left of it. Don't sit on it. You must go left and right. I'm going to go to the right of it. And I'm going to guess. I'm like, yes. And it says, here's your minimum. Your minimum is located at x equals 2.15. So I'm just going to write at x equals negative 2.15. Okay, I don't feel like writing the whole thing out, so I'm just going to leave it like that. If I need to find the y value, I can just plug it in, right? Okay, now we're going to do the same thing, but this time we're going to find a maximum. Second trace 4. I'm going to go to the left of it, then I'm going to go across to the right of it, and we end up at x equals 1 and 549, about at x equals 1 and 549 thousandths. Okay. Doable?
Yep.
So my sketch again is gonna be a little
Oh, that's beautiful, miss.
beautiful. I'm zoomed in. This is the zoomed in mode.
Oh, yeah.
This is zoomed in. Okay, yeah.
Like very,
Thank you,
very,
thank you.
very.
That's why what's written on the side is important. Okay, okay. But do we get it? Okay, you're gonna do it again now on B. Go.
That's too hard.
All by your lonesomes or with your table mates.
Yeah.
All right, so here we go. Again, N is referring to your degree. What is the degree here? It's even, and why is it even? Because it's 4, right? A sub N is referring to our leading coefficient. What is our leading coefficient? Positive or negative? Positive, and that's because it's a positive 1, right? Okay, based off this information, can I determine what my behaviors are doing? Yes. So my right side is going up, and because it's even, my left side is also going up. So the limit as x goes to negative infinity of this function, what is happening on my left-hand side? It's going to positive infinity. And then what's happening on my right-hand side? Positive infinity, okay? So thinking about this, turning points. What is my max number I can have? So max number is 3, and why is that? Degree minus 1. So when we do our little graph and our little sketch, again, whatever I draw is either going to be a zoomed in or zoomed out version. So if it doesn't look like you think it should, just keep that in mind. So we have x to the 4 minus, is it 3x cubed, right? 3x cubed plus 2x. Minus. Thank you. And there we go. So we have, come on, Sylvie. Why are you thinking so long today?
She's tired.
All right, there is Sylvie. So how many turning points did we have? We had the maximum. Did y'all find those values? Yeah, what are your x's? -2.14 and yeah, I was like, this is positive, right?
I did min.
Yeah. To do it twice, gotcha. All right, yes. All right, and here's my attempted sketch. Don't worry. Beautiful. It's gorgeous, huh? It's a positive 0.54. Yeah. No, it's not due tonight. All right. All right, we're gonna get out in 3 minutes. So tomorrow when we come in, we're gonna reiterate the fact that our turning points is what again? What do we say about our turning points? The max. It's our extrema, and the highest you can have is our degree minus 1. Yes. So then we're gonna review multiplicity, and then we should be ready to finish out.